solving rational functions, the easiest way to solve is to get rid of the fractions and turn this into a linear or quadratic of something I know how to solve. Okay. So when you're doing this, you kind of ask yourself a question. You kind of look at the problem and think, okay, what do I have on the bottom? And in this case, I have a 4 and an 8 on the bottom. So what you're going to do is take what is ever in the denominator and multiply all the terms by that, and that will eliminate the fractions. So in this first one, I see that, oh, on the denominator I have a 4 and I have an 8. So you pick which one you want to do first. It doesn't matter. 4 or 8, which one? 4. Okay? So what we're going to do is take every single term times 4. Okay? And how that helps us is if I have a 4 on top and bottom, what happens? 1. They cross off and it equals 1. Very good. So this crosses off, and I'm going to end up with this. 1 minus 4x equals 4x over 8. See how I got rid of one of the fractions? And then I start again. What do I still have on the bottom? 8. An 8. So I'm going to take every single term times 8. But if 8 is on top and bottom, what happens? They cross off, and I have this. 8 minus 32x equals 4x. This started off kind of complicated to something very simple. This is just a basic Algebra 1 problem solved for x. So I add 32x and get 8 equals 36x. Divide by 36, so x is what? X would be reduce 836 to 2 ninths. Good. There's your answer. And so again, what do I have on the bottom? I have a 5 and I have a 2. Which one do you want to do first? 5. So I'm going to take every single term times 5. But if I have a 5 on top and bottom, what happens? They cancel out, so I get this. Y equals 5y over 2 equals 35, okay? And then I start over. What do I have on the bottom? What do I still have on the bottom? A 2. So I'm going to take every single term times 2. But if I have a 2 on top and bottom, they cancel out, and I end up with this. 2y plus 5y equals 70. And again, that's a very simple linear function to solve. I add 2y plus 5y, which is 7y. So y equals 10. Have a rational function equation like this and see what the common denominator is, you can do everything in one step. So do you see how I have a 3 and a 2 and a 6? What's the common denominator between 3, 2, and 6? 6. So to eliminate steps, if you see what the common denominator is, you can do everything in one step, right? It'd be the same thing if you multiplied by 3, multiplied by 2. You still get the same. Multiply everything by 6, you're going to eliminate the denominators. What's 6 divided by 3? 2. So this becomes 2. What's 6 divided by 2? 3. What's 6 divided by 6? 1. That cancels out. So with one step, I get rid of all the fractions. So this now is 2 times 2x, which is 4x. That's just a 3. And then that's 2x plus 5, okay? So see how instead of doing multiple steps of multiplying, we can just do one step of multiplying and get rid of all the fractions? If you don't see that, that's fine. Just do the way we've been doing it. I just wanted to show you because some of you are ready for that. Get my x's on one side, get my constants on the other side. So 2x equals 8, so x is 4. Very good. The number 13 example, you should notice what do I have on the bottom? 3 and an x, and this one has 2 x's actually, okay? So I'm going to multiply everything by what? Which one do you want to do first? 3? Multiply everything by 3. So 3, 3, 3. But if 3 is on top and bottom, they're going to cancel out, right? So I'm going to get 11 over x minus 1 equals negative 12 over x squared. Now I'm going to multiply everything by an x. So multiply by x, multiply by x, multiply by x. These x's are going to cancel out, 11. One of these x's are going to cancel out. See that? Just one of them. So I'd still have negative 12 over x. And then one more step, I multiply everything by x. Those x's cancel out. 11x minus x squared equals negative 12. So
Swiss Army.
what you could have done is you could have multiplied everything by 3x squared if you saw that was your common denominator. And if you multiplied everything by 3x squared, you would go from here to here if you did do that. Okay, if you recognize 3x squared was your common denominator. But what you should see here is this x squared, and this is a quadratic. Okay, so when I get quadratics, the key is I want to make x squared a positive 1, and I need all my terms on one side set equal to 0. So what I'm going to need to do is I'm going to need to add this x squared over to this side, minus the 11x over to this side, then put this into standard form, and then factor to solve. So what do I multiply equals negative 12 but add equals negative 11? Negative 12 and 1. Very good. So if I factor this, what does x equal? 12 and negative 1. 34. I have two things on the bottom. What are they? X and x plus 2. Which one do you want to do first? X. So I'm going to multiply every single term times x. But if x is on top and bottom, what happens? It cancels out. So these are gone. And these are gone. Okay. So now I start again. And okay, what do I still have on the bottom? X plus 2. So I'm going to take every single term now times x plus 2.
Why did the x's cancel?
Because there's two of them.
On the first one.
So those are gone. Those are gone. And I get 2x minus parenthesis x plus 2 equals negative 4. Why do you need parentheses? Because I'm subtracting this whole term. And the whole term would be x plus 2. So I'm subtracting the x and I'm subtracting the 2, so you need parentheses there. And then you're going to finish solving this by distributing that negative through, so 2x minus 2. And this turns into something simple to solve, linear. I can combine 2x minus x into x, add the 2 over and get negative 2, and then I'm done. X is negative 2. But what is wrong with that answer? Why is that bad?
It's a negative.
It can be a negative, but what's wrong with negative 2?
It's on the bottom.
If I were to take this negative 2 and plug it back in to solve, what happens? I get 0 on the denominator. Can I ever have 0 in the denominator?
No.
So this is called an extraneous solution where, oh, it doesn't work and it's actually no solution. You have to check your answers to make sure they do not make a denominator 0.
I'm not up for checking.
Example 48 here. You have two things on the bottom. What are they?
K plus 1.
K plus 1 and K minus 2. Which one do you want to do first?
K minus 2.
Okay, so I'm going to take everything times K minus 2. K minus 2.
Oh, I hate this already.
K minus 2. But if I have K minus 2 on top and bottom, what happens? They cross off. This I need to multiply k squared minus 2k. This just is now k. And I need to multiply this, 2k minus 2. I still have one more thing on the bottom. What is it?
Wait, hold your horses.
Wouldn't that be 2k minus?
Minus 4. And then, right, I would multiply by k plus 1. So I take all the terms times k plus 1. So that crosses off. I get k squared minus 2k. This multiplies k squared plus k. This multiplies 2k squared plus 2k. This multiplies negative 4k minus 4.
Wait, what?
Why can't we just
Looks super complicated, but what happens,
Like,
do you guys see it? If when I combine my k squareds and get 2k squared and subtract it over, it's actually going to cancel out. Okay? So this problem is not as bad as you think. 2k squared, combine my k's, right? So minus k equals 2k squared, combine my k's, minus 2k minus 4. And then I need to get my terms together. So I'm going to subtract the 2k squared, and those just end up canceling out. Get my add 2k over. So it's just k, and then what's left is negative 4. And can k be negative 4? Is that okay? Yes, that doesn't make a denominator 0. That is a good answer. Last example.
However, it
Of
goes
course, to see what's on the bottom, you do need to factor if anything's factorable. So let's factor this. What do I multiply equals negative 12, but add equals negative 1?
minus 4.
Negative 4, positive 3. So you really only have two things on the bottom. X minus 4 and x plus 3, because see how these two are exact opposite? So remember that trick I showed you? Whenever you have a binomial that's exact opposite, you can pull out a negative and make them the same. Because this is a positive 4, that's a negative 4, this is a negative x, that's a positive x. So the trick is I can pull out a negative, which would make this negative and this positive, and now they match. So what I have on the bottom is x minus 4s and x plus 3s. The other thing then you need to do on this is now see how now this becomes a double negative? So this is actually going to be a plus. Okay, so two things happen there to make them the same. Then you're back to what's on the bottom, x minus 4, x plus 3. Which one you want to do first?
X minus 4.
X minus 4, okay.
That trash out of
So
the way.
x minus 4, x minus 4, x minus 4. And again, if they're on top and bottom, they're crossing off. So this becomes 2x minus 8 over x plus 3. This is just now plus 3. And then this one is 2x minus 2 over x plus 3. And then one more step, what's still on the bottom?
Wait.
X plus 3. So I'm going to multiply everything by x plus 3. But if it's on the top and bottom, it's going away, going away. So what's left? 2x minus 8 plus, I have to multiply 3x plus 9 equals 2x minus 2. And again, this is a basic Algebra 1 problem. You just need to get your x's together, get your constants together. So combine like terms, 5x. Combine constants, plus 1. And then I would, let's see, subtract 2x to get my x's together. Subtract 1 to get my constants together. So 4x equals, no, 3x equals negative 3. So x is obviously negative 1. Is it okay for x to be negative 1? Yes, that doesn't make a denominator 0. It's okay.
Wow.
Last example I want to do here again, you need to look at the denominators and factor. So this one I can factor out a 2. This one is difference of squares. y plus 4, y minus 4. And again, this one, I can factor out a 2. Okay. So I actually have 3 things on the bottom. I have 2, y plus 4, y minus 4. So you pick which one you want to do first. Y plus 4, okay? So let's do y plus 4, y plus 4, y plus 4. And again, if it's on top and bottom, it's going to cross off. So then I have 10 over 2.
You talking to yourself?
7y plus 8 over y minus 4 equals negative 8. Let's multiply that. Negative 8y minus 32 over 2y minus 4. And then you pick, there's 2 and y minus 4, so pick another one. Y minus 4, okay, so y minus 4, y minus 4, y minus 4. And again, if it's on top and bottom, it goes away. So this would, let's multiply 10y minus 40 minus 7y plus 8. That should have been in parentheses. Equals, that's gone, negative 8y minus 32 over 2. And what you can do, you can go ahead and divide by 2, or you can multiply by 2, your choice. Because if you notice, if you're dividing by 2, that's 5. That becomes 20. This negative gets distributed. 8 divided by 2 is negative 4, and that becomes a negative 16. So again, linear, you got to combine the y's here. So 5 minus 7 is negative 2y. Negative 20, negative 8 is negative 28. And then to solve, I would add the 4y over. So I get 2y, add the 28 over, and get 12, divide by 2, and I get y equals 6. Is that okay for y to be 6? And it is. That's okay.